Next, let's look at the simulation periodic. So public so the simulation periodic will just keep running whenever you are running a simulation. So first, let's set the inputs for the elevator sim, which is the voltage. Elevator from the motor. Motor and the battery voltage. So this set up the inputs for the elevator simulation with the output voltage from the motor and the battery voltage. And this output should be a value between -1 and 1. And next is update. So it should be every 20 milliseconds. And then is update the motor with the velocity. So the motor sim, yeah, and we're using iterate. So we want to get the velocity for the elevator, and we're going to set up a function, or actually a method, yeah. So public because we wanted our velocity to be in meters per second, because we're like basically using meters for elevators. So we have to do some conversions. So we get the velocity from return. Yeah, okay. We get our velocity from the encoder. Yeah. Encoder, get velocity. Okay. And that's in rotations per minute. So we want to convert it to meters per second. So from minutes to seconds, we just divide 60. And from rotations to meters, so it's from a rotational displacement to a linear displacement. And so if we have a circle here and 1 rotations, is the linear distance should be like the circumference, which is 2 pi times the radius. So if you have 2 rotations, then it'll just be 2 times the circumference. So that's how you are going to do the math here. So you know this one, you know the rotations, so you just convert it to the distance, linear distance, with 2 pi r. So 2 pi, and the radius should be the drum radius. Okay, and that's not done, because if you remember, we also have the gear ratio, so it should be divided by the the elevator constants. The gearing. So why do we divide it by the gear ratio? So if this is a motor and it's attaching to an elevator, every time the axis has turned 1 revolution, the internal gearing will just turn whatever the gear ratio is. So why we are dividing that is because the encoder is actually reading that many distance. So we need to divide that to get this one. Okay. And let's also set up for, let's also set up the get position. It should be meters return get position, and the same thing. And let's go back to iterate. So for iterate, we need velocity, which is in RPM, the battery voltage, and the simulation time period. So since we're using meters for the elevator, and if we want RPM, we can just take the velocity and convert it back to RPM. So meters of get velocity per second, and we want it to be in RPM. Well, it doesn't have rotations. RPM. Okay, RPM. Okay. And we need the angular velocity. So here we are using linear velocity, but we want it to be in angular velocity. So yeah, and that introduced the idea of robot math. So there is a lot of unit conversions between the linear distance and the rotation. And in robot math, we have like convert angle to sensor unit. So we just need to put the arm reduction here, and this one is convert sensor unit back to angle. So it's the opposite. And yeah, so we are going to do the same. Public so we want it either to be in rotations or the linear distance. So let's first do rotations to distance. Yep, because we have to have both of them. Public, and it should be in distance. And we want one parameters which take the rotation. And what we are going to return is the same thing we have done before. So it's like the same similar process. Like we're taking the rotations and convert it to linear distance. So let's take the rotations and give it a unit. And then we need to convert it to distance. So remember, for rotations to be linear, we just times the circumference and some gear ratio. So and then, so I think I would say this is in meters. Oops, what happened? Yeah, we need to convert it to distance. So it's in double. So we just add meter. Yeah, it's a distance unit. So of a value and that should be good to go. And similarly, we are going to convert distance to rotations. So public convert distance to rotations and take distance. Return. So this time it's like the opposite. So you have the rotations, you times the radius, and you divide. So if you have the distance, you times the gearing, and you divide by this one. Yeah, and we need to use distance, so convert it back to a double. Wait, it should be in meters. Okay, and we need to convert it back to doubles, so the value and this should be good to go. So let's go back to iterate, and so we wanted to convert the linear to rotations. So we wanted to import the robot math. Robot math, and elevator. So I'll just put it here. So elevator, and we should use distance to rotations. And that's what we wanted to put. Meters to here. Okay, that looks good. So we convert this thing to rotations, and then we use per second, and we convert it to rotations per minute. And that's not done. Because it should be it's like so weird. So battery. So roboreal sim get, and then the third argument. Yeah, is this good? It's still not. What am I missing? 1, 2, 1, 2, 3. Wait, 1, 2, 1, 2, and iterate. Okay, this one, right? Okay, and that's our simulation periodic. Another thing for the simulation periodic is you need to set the roboreal sim, the voltage for the battery. So we are not using get. Here we are using set. Okay. Oh yeah, set being voltage. So it's like set the input voltage. Okay, and I'll just type battery default battery. Yeah, so it should be from the currents, which is from our elevator sim and get. Yeah, amps. And yeah, and that should be for the simulation periodic. And of course, I update our laser can, our sensor simulation. Yep, and so next we're going to look at the mechanism 2D. That is why you're seeing shapes on the screen. So we're going to create it in the constants file. But first, let's learn how mechanism 2D works. So the first thing you have is a Canva. And to create an elevator, you have a root, which is the point you're attached the elevator to, and our elevator. Which is called the ligament. And that's it. But usually, for robots, we'll have like elevators and arms. So instead, we'll have something like this. So this is the pivot point, which is the root, and our elevator, the ligament, and our arm, another ligament. So you might be wondering why we couldn't create like that from the bottom, like burr. That's pretty bad. Okay, burr. That is because of the root. So as you can see, this one used 2 root. That means we have to create 2 roots for the mechanism. So instead, on the left, we have only 1, and it still works. So we're going to do that. And it works like that. So starting from the bottom, we have the pivot point, and when elevator goes up, so when elevator needs to go up, it's actually the pivot point. It goes up, and the elevator will set to the length you want. And yeah, that's something just be aware of, because it's not like the usually, like, if you started from bottom and you from bottom you reach it to your height. It's like the opposite. It's from the top to the bottom. Okay. And next is the size of the Canva. So for the size, if you think of the actual things, so this is the elevator height, like the maximum height, and this is the maximum height for the arm, and that's our maximum height for the Canva. And for our width, our maximum length for the arm, but we double it, so it will be like that, and that. So it would be like, so for this side is the elevator length plus the length of the arm, and for this side is doubles the arm length. Yeah. So now let's create a mechanism 2D. So mechanism 2D, I'll just call it side view. So new mechanism 2D, and the width is our arm constants times 2. See, arm constants. And height is elevator height. Actually, elevator length. We don't have that. So public static so for the coral we're using a double, and we have 31 inches. So I'll just do similar things. And I'll just put like 33. So, and it should be like plus, yeah. Remember, elevator length plus the arm constants. No, the arm length. And next is our root. Yeah, so see the ligament and the root. I'll just call it elevator carriage. Actually, I'll just create. Yeah, we'll initialize it later, because we can create all of them. Yeah, we'll just create all of them at once. And next is the ligament, which is, let's do the elevator first. And this one should be ligament 2D. No. Let's call it elevator movement. And our arm. Yeah, I'll just create like, because usually the robots have like elevator and arms, so I'll just create one for the arm. Actually, I'll just rename it because we have some good names. So this one we can call it like elevator tower or just like elevator Mac and arm Mac. Yeah, I like those better. So, yep. And next is our initialization. So we have the static variable, yeah, static instance variable. So we have the static here, so we need to use static method. So first, our elevator carriage. So elevator carriage, and it's based on the mechanism 2D, the side view. So constants side view. Yeah. So first we get the root, and we call it elevator carriage. And the x and y is the coordinate. So if we think of the start of the Canva, so the carriage should be like right there. So the x is like x, and the y is like, so it has nothing. So it's like 0. Yeah. But we are just not. We'll put something instead of just 0. And so x is our LG arm constants. Yeah, the length. And y is our elevator starting height. So constants. Yeah, I guess I'll put this one. So the starting height is starting height. So starting height sim. Yeah, sim. Should I put meters? So here it has the starting angle. Okay, I'll put meters probably, because here it specifies the units. So it's like distance. Meters of same 0.0. Does that work? Yeah. That works. No. That's not what I want. Yeah. That's not the starting. Yay. So yeah, another conversion, because we need double. Ooh. Where does it go? Does that work? It doesn't. What's wrong with it? Oh. Wait. Oh, actually, it should be in meters. Oh yeah, so this is the distance converted to double. So meters, my bad. Is that good? Meters. Yay, it works. Okay, wait, what? Actually, yeah, that looks good. Yeah, 2 parentheses. Okay, and next is elevator. So for the ligament, we just appended. It's like it means like adding on something. So carriage append, see? And we need to create a new ligament. So new ligament elevator. So the length should be the length. So length, and it should be the starting angle. I don't know why it doesn't show up. Okay, it's the angle. So for the elevator angle, oops. So if you think of that, you're starting like right here. No, actually, you're starting right here. And the elevator, so the pivot point and the elevator should be like here. So, because it's always like you move the pivot up and you extend the elevator down. You move the pivot up and you extend the elevator down. So it's like the opposite of what we usually, or maybe you are thinking about. It's not like that. It's not starting from the bottom, it's starting from the top. So for the angle, if you think of the unit circle, so this is 0, so that's -90. Oops. Okay, and I'll just put it yeah. Okay, starting angle. What is it giving? This starting angle. Yay. Okay, so in degrees. And we should need more. Oh, maybe because I clicked the wrong like remember it gave me some choices, like the drop down, and I clicked the wrong type. So I'll just type it in. It's kind of awkward. So, and we need the line width and the color for your elevator. So line width, I'll just put 5. See, line width, and the color. So we have a new color. Ooh. And we need color. Let's put it. Where's my red? Go back. Yay. Okay. And finally is our arm. So arm neck is the same thing, like append from the root. Yeah, see, this one provide like line width, straightening, arm length. Oops. LG arm constants, arm length. An angle? I think we have an angle. Okay, starting angle. In degrees. Starting angle, and we need line width 5, and a color. So new color, blue. And that's for initializing the mechanism 2D. And then we need to update it in our simulation periodic. So what we need to update is the arm, we just leave it to our arm subsystem, and what we need to update is our pivot and our elevator. So, and it's from the constants file, so constants. Yeah, we need our elevator mech. Set length. Yeah, set length. So the length should be, yeah, from what these. So get position meters. And update our carriage. And this should be set position. So if you think of that, so the carriage, it just keep moving up, down, up. It just the x value, it doesn't change. The only thing that are changing is the y. So that's why here we set it to the same, half of the width, which is the arm constant. Yeah, the arm length. And our y, we can get it. It's actually the same as the elevator. So if you think of that, the elevator go this high and the pivot go this high. And if the elevator go this high, the pivot will just follows. So we'll just put the same methods here. Yep. And I forgot to, yeah, and that's for our mechanism 2D.